Okay, so now at this point you should be fairly good at calculating pH. And you should understand that pH is a measure of the relative strength of an acid or a base, or the relative amounts of acid or base. So if you have a pH of 0, that is a very low pH, means you have an awful lot of H3O plus floating around. If you have a pH of 6, you still have technically an acid, but you have a lot less H3O plus, and so it's a lot less dangerous, so to speak. Just like we'll talk about bases in the next movie, but bases are the same way. The closer it is, the farther away from 7, the worse it is. So if you have a pH of 14, technically it's a base. That stuff's Drano, man. It's bad news. But if you have a pH of about 8, well, you know, milk has a pH of about 8. It's not that bad, okay? So it's all about figuring out what their pH is and how it relates to the strength of the acids. So strong acids like HCl or stomach acid completely break apart into H3O+, and that right there determines your pH. 100% of the strong acids turns into H3O+. So all you do is negative log of the H3O+, and you've got your pH. Easy peasy. Weak acids, on the other hand, don't completely break apart. In other words, they set up an equilibrium. And that equilibrium between the reactants and the products tends to favor the reactants. So any weak acid, A meaning acid, doesn't mean element A. There is no element A. It's H with an anion. Doesn't even matter what it is. Plus water. This acts like an acid, donates a proton, and here we get our stuff. This determines the pH. So what we're going to have to do is set up an equilibrium in an ice table. So the strength of the weak acid depends on the ratio of the products to the reactants. The bigger the Ka is, the stronger the acid is, because it produces more of that. That is the stuff that will kill you, the H3O+. Okay? The larger the value of Ka, stronger the weak acid is. And I use weak in quotes because they vary greatly on how weak they are. And any acid that is not one of the strong 6 is a weak acid. Any acid, and there's an awful lot of them. Okay? You can also identify weak acids because they always mention the word Ka. So if I had to calculate the H3O+ for this one, you're going to do exactly what we've always been doing. You're going to set up an ice table. You're going to recognize that water is a liquid, so we don't care about it. The HNO2 starts out at 1.5. These guys start out at 0, and again, pH is based entirely on this. We need to know how much that is. Minus X, plus X, plus X. You get 1.5 minus X, X, and X. So when you set this into the Ka, which is products over reactants, you get 4, whoops, what was that? 4e negative 4 equals the two numbers on top, x squared, over 1.5 minus x. Now you might think, oh, wait a minute. I have to cross multiply and distribute, and it's a quadratic, and oh my god, that stinks. But this number is really small, so you can say assume x equals 0 with respect to 1.5. What that does is it takes this out of the equation. So now all you need to do is cross multiply. You get 6e negative 4 equals x squared. X is therefore 0.0244. So if I was to put it in my IC table, 0.024, 0.024, and if I wanted to subtract it, I got 1.48. So it doesn't make a huge difference. I mean, it makes a little bit of a difference, but not a huge difference. But what I am concerned about is the H3O+. Okay? And I'm going to set up an ice table, and I'm always going to put an X under water because no one cares about water. And these numbers are always going to be so small that you can assume X equals 0, which means that part of the equation goes away and all you have to do is cross multiply and take a square root. So let's try this one. Okay? There's the reaction. I'm going to set up my IC table. Water gets a big X. 2.5 molarity. This is acetic acid, vinegar. Subtract X, add X, add X. At equilibrium, you got 2.5 minus x, x, and x. Putting them into the Ka, products over reactants, of x squared over 2.5 minus x equals 1.8 e negative 5. And again, x equals 0 with respect to 2.5. So that goes away. You're going to cross multiply. And take a square root. And x equals 0.0067. Goes right here. And if I wanted to subtract, I get 2.4933. Something like that. Okay, doesn't make a huge difference. So they wanted to find the H3O plus. Here it is. I have found the H3O plus. They also want me to find the OH minus. Okay, so now remember back. When we were doing that chart with pH on it, all I have to do is give you one of the values and ask you to find everything else. And if you remember, H3O plus times OH minus equals 1e negative 14. So if I put in 0.0067 times my OH minus, all I need to do is take that 1e negative 14 and divide it by the 0.0067. And you get 1.5 e to the negative 12. Okay, so you have to pay attention to what they're asking for and bring back old stuff. Okay, now we're going to do a different kind of problem. HCN, H2O, H3O plus, and Cn minus. I'm telling you what the pH is. I want you to find the H3O plus. Remember, on that chart, there's 4 different variables: pH, H3O plus, OH minus, and POH. I can give you any one of the 4, and there's 2 ways to find everything else. But I'm going to find the H3O plus. So the H3O plus is 10 to the negative 4.6. That's how you find the H3O plus. And you get 2.5 e negative 5. That's the H3O plus. Now to find the Ka, I'm going to set up this reaction again. Big X here, icy table. This is 1.0, 0, 0, minus x, plus x, 1 minus x, and x. The Ka is products, x squared, over 1 minus x. And guess what? H3O plus, right there, that's what x is. I'm going to plug in 2.5 e negative 5, square it. And if I want, I could do 1 minus 2.5 e negative 5, but that's not going to make a huge difference. I get 6.3 e negative 10. Okay? So paying attention to what they're asking for and what they give you is important. So go ahead and see if you can set this up. They give you the pH right here, and they want the Ka. So if you set up the ice table, or the icy table, Ka is x squared over 1.25 minus x. The problem is they don't tell you directly what the H3O plus is. They tell you the pH, and if they tell you the pH, you can find this. The H3O plus is 10 to the negative 3.47. You get 3.4 e negative 4. That is referencing x. You get 9.2 e negative 8. Okay, and that's how you find the Ka.